Hello everyone, so we've got a Key Stage 4, Key Stage 5 video here on how to calculate work done and power. Now work done, I'm going to discuss, and we're going to use red, and power we're going to use blue just to distinguish between the two. Now work done is another way of saying the amount of energy transferred. When you transfer any energy, you're doing work. When you lift a pen, you're doing work. When you drive in a car, you're doing work. When kinetic energy changes into heat energy, for example, we're doing work per se. Now, when a force moves something through a particular distance against another force, like friction or gravity, then we say that energy is being transferred. So if we have a downward force, like a weight, and it's, let's say we've got something falling through the air and it's got air resistance pushing back, it's got the force of gravity pushing down. When we get that particular scenario, what we get is energy being transferred. So we have to have a force moving through a particular distance. So our formula to work out work done, right over here, work done is equal to the force multiplied by the distance moved. And that distance is in the direction of the force, and that's key. So it's in the direction of that force. Now, as always, let's think about some units for this. So if we've got a force, and that would be measured in newtons, typically. We've got a distance, and we usually measure that in meters, so we'll put a little m there. Then you can see that that would give a unit for work done of Newton meters, or what we could refer to as joules. If work done is ultimately another way of saying amount of energy transferred, and energy is measured in joules, then we can just record work done in joules. So there's our formula for work done. It's the force times the distance moved in the direction of that force. Now power is the amount of work done in a given time. So we've said what work done is. We said it's a force, or the amount of energy transferred when a force moves through a distance. Now the rate at which that happens, so we've got the rate of doing work, as it says in the power description, that gives us the power. So the amount of work done we do in a unit time. So we can now say that power, if we write down the formula for that, power is equal to the work done, which is the same as saying energy transferred. We could put brackets, energy transferred, it's the same thing. It's the work done divided by time taken. Now let's put, again, units to that. So we've got work done, which we said was going to be measured in joules. We've got time, typically measured in seconds. So we could say that's joules per second. But what we're going to do is give power its usual unit of watts. And that's W-A-T-T-S, watts, for power. And that has a symbol of W. Now, it should also be noted that we can use and substitute for power particular letters in place. So you might see this power written as, and I'll write this in green just above, you might have seen power written with a P, put in a square there. Work done or energy transferred, you might see as an E, and time would be a lowercase t. So often you see this equation written as P equals E over T. So there we have, very simply, how to calculate work done and power, the two essential formulas. So the one at the top for work done, the one at the bottom for the power. Now let's put this into a context. Let's think of some questions that they could actually ask you. So I'm just going to go through two particular examples of questions where you're using these calculations. So we'll just shrink the screen a little and move that up to the top, like we normally do. Let's do a work done question first. So a typical question that they could ask is a TV with a weight of 300 newtons. So this is question 1. So we've got a TV here, just draw a little picture. The person on, there's some buttons there. TV's weight of 300 newtons, so we'll write down what we know about it. Is lifted onto a wall mount. So there's a wall, we've got a wall mount here. That is 1.2 meters from the ground. So we're told that's 1.2 meters from the ground. Calculate the work done. So quite simply, work done is equal to force times distance moved. So we put F times D. The force is 300. The distance is 1.2. And if we do 300 times 1.2, then that comes out as 360. Now don't forget the units, that's 360 joules. And that is quite simply how you do a calculation to find work done. Let's have one where we actually need to consider our power this time. So we've got a man pushing a wheelbarrow does 400 joules of work in 5 seconds. So we've got a guy here with a wheelbarrow, and we're told that he does 400 joules, or uses 400 joules of work, and it takes him 5 seconds to do so. Power, quite simply, is work done over time taken. We'll actually use the symbols for this one, so P equals E over little t, which would be 400 divided by 5. So when we do 400 divided by 5, what we get is a value of 80, and that's 80 watts. Remember, we need to include the units. It's essential that we remember to include the units in each case. Now, you may have to use these two equations to work out something a little bit more in depth. Like, for example, it may give you a distance off the ground, for example. It might ask you to work out how much work is done, but you may be given a mass. Now, I have done a video to explain that force is equal to mass times acceleration. Now, if an object is acting against gravity, then we would use gravity as the acceleration. So we've got a value of 9.8. So all you would have to do is times that value by the mass, and that would give you the force. If you know the force and you know the distance, you can then work out work done and so on. And then you can substitute the value for work done into power. But I do have a separate video on that. Okay, hope all that helps.